Welcome back. This video, we are going to be focusing on polynomial functions. So a polynomial function, what is that? Polynomial. Poly means multiple. So this right here means multiple, poly. And nomial means terms. So a polynomial is something that has multiple terms. The general equation for a polynomial looks really ugly. I don't want you to get confused with this. I'm going to write it out so you know. But it says that you have one coefficient times something to some degree. And then you're going to have another coefficient. And the n minus 1 just means that it's not the same as the first coefficient times some other term with a lower degree. Plus another coefficient and another term with an even lower degree. And this can go on forever. A polynomial can be simple. It can be something like f of x equals x plus 1. That's a polynomial because you have a linear term and then you have a constant term. A polynomial could be f of x equals x squared plus x plus 1. You have 3 terms there, and it's quadratic. A polynomial could be a cubic. That's a polynomial. So a polynomial could have any degree. And that's what the n is, nth degree. It can be any degree whatsoever. And it can have any number of terms, really. Now, here's the tricky thing. A polynomial doesn't have one set shape. A polynomial will take the shape of whatever the highest degree is. And so it's important that you know a little something about your degrees. If you have an odd degree, and an odd degree meaning the highest degree is odd, the ends of your graph are going to end in opposite directions. So we're going to say the end behavior is opposite. So for example, if you have a degree of 1, that's linear. That's linear. And that looks like this. Our ends are in opposite directions. We have one end over here that is going forever in the negative direction, and we have this end over here that's going forever in the positive direction. Okay? That is not the only odd degreed function. X cubed is an odd degreed function. That's going to be cubic. And that function looks like this. That's a cubic function. And again, you will notice that the ends are in opposite directions. It could be x to the 101 power, and the ends are still going to be in opposite directions. Now, if you have an even degree, and the first even degree that I think of is x squared, so like x squared, your ends are going to end in the same direction. They are going to end in the same direction. Sometimes that'll be they're going to end in the positive direction. If this would have been negative x squared, then they would have ended in the negative direction. And so if you have an even degree, end behavior is the same. So an even degree, the end behavior is the same. Now here's the deal. A polynomial is going to have mixed degrees. So you have to focus on the highest degree. Focus on highest degree. Okay. All right. So a couple of things just in the verbal representations. F of x is read f of x. So f of x could be a polynomial function of x. And then if n is 3, So that would be your highest degree. If your highest degree is 3, then you'd call it a cubic polynomial. If n is 2, you'd call it a quadratic. N is 4, you would call it a quartic. And you can go on forever. But you're really specifically looking at your highest degree. Now, there are some really cool things in the graphs of polynomials. We already talked about end behavior. So end behavior you can tell in the graphs of polynomials. You can also tell the shape. You can tell the shape in polynomials. Let's write down a couple of just key features that you should know for polynomials. So polynomials, the graph can cross the x-axis up to n times. The graph can cross the x-axis up to n times. What that means is if you have a cubic, you might have 3 x-intercepts. If you have a degree to the 7th power, you might have 7 x-intercepts. So the graph can cross the x-axis up to n times in a polynomial. That's pretty cool. A vertice, a vertex, is a min or a max on a curve. The graph of a polynomial can have up to n minus 1 vertices. So quadratic, you're going to have 1 vertice. A cubic, you could have 2. You might have 0, but you could have 2. A quartic, you could have 3. And then the domain, and this is a big deal. This is a big deal. In pre-calc, we talk about domain a lot. The domain of all polynomials is all real numbers. So I encourage you now to go and graph some polynomials and make some conjectures. Graph them and see what happens to your ends. Do they do the opposite and the same as we predicted? What happens to the insides? See if you can get them to cross 7 times, 8 times. So go on Desmos, go on a graphing calculator, and practice just looking at what the graph of a polynomial looks like.